Okay, guys, we are continuing on with 1.6. So we've now done sine, cosine, tangent, and we're going to do the three reciprocal functions, starting with the graph of the cotangent function. So your thought should be probably, oh, I bet it has some kind of similarity to tangent, and you would be correct if you thought that. However, there is maybe like one, well, I mean, there's lots of differences, but maybe one big one. Think about your identity functions. Tangent of x tangent of x is equal to sine of x over cosine of x. So we knew we had undefined values when cosine of x would equal 0, and that's where our asymptotes came up. But with cotangent of x, because it's the reciprocal, that means it's equal to cosine of x over sine of x. So that means our vertical asymptotes are going to occur when sine of x equals 0. Okay, so think about when would sine of x equal 0? And sine of x equals 0 at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. So multiples of pi. Okay. Oops. This is what the graph looks like. So notice you've got your 0 is here. Here's your origin. You've got an asymptote, which they don't actually have drawn in, but you should. And then at every multiple of pi going forward and backward. The period is therefore still pi. You're repeating every pi units. Your domain is all x except for at the asymptotes, which n pi is just saying any multiple of pi. Your range, because you continue on vertically and horizontally forever, is all real numbers. Our vertical asymptotes we've already talked about. And symmetry is about the origin again. Okay, hopefully you can see that. We're going to go about graphing it the very similar way in that how we did the tangent. Remember that when we graph tangent, in order to, once we throw in some other numbers, in order to find our vertical asymptotes, we solve the equation bx minus c equals plus or minus pi over 2 to find two consecutive vertical asymptotes. For cotangent, it's pretty similar. It's bx minus c equals 0 and bx minus c equals pi is how you're going to find your two vertical asymptotes. So same steps that we did before, just using these new formulas. And why is that? Well, if in your basic tangent function, your asymptotes are at multiples of pi over 2, and in your basic cotangent function, your vertical asymptotes are at multiples of pi. Okay, so you could solve these to find two vertical asymptotes that are consecutive. Alternatively, you really could do pi and 2 pi, 2 pi and 3 pi, 3 pi and 4 pi, because that's where the original ones are. This is going to be the basic, easy way to find it when you're going to be close to your origin. Okay? Looking back at the basic graph here, again, you can see that halfway between your vertical asymptotes is an x-intercept, just like with tangent. So those are what you're going to start by finding. Start by finding two consecutive vertical asymptotes halfway between your x-intercept, and then try to find probably two more points. And then repeat every period. Let's try one. Oh, I just showed the answer. Here we go. 2 times cotangent of x over 3. Now, remember, the first thing we want to find two vertical asymptotes. To do that, we're going to solve the equation bx minus c equals 0 because it's cotangent, and we're going to solve bx minus c equals pi. Okay, well, bx minus c in this case, remember, by the way, what the basic form with these a's, b's, and c's. It's a, y equals a times your trig function, and then bx minus c. So bx minus c is what comes after right here, what you're taking the trig function of. In this case, it's x over 3. X over 3. To solve this, you're going to multiply by 3, you get x equals 0. Multiply by 3, you get 3 pi. So what does that tell you the period is? Hopefully you're thinking 3 pi. If you've got your vertical asymptotes at 0 and 3 pi and you know they're consecutive, then that means your period is 3 pi. Okay, so you're going to be repeating your values every 3 pi units. Okay, so if you're making a little chart, if we've got x and our function y equals 2 times the cotangent of x over 3, we know at 0 it's undefined, which means we have an asymptote. And we know at 3 pi we're undefined. So we go halfway between that, halfway between 0 and 3 pi. Well, 3 pi over 2. We know that has to be an x-intercept, so that's 0. Halfway between 0 and 3 pi over 2, well, 3 pi over 2 divided by 2 is 3 pi over 4. And halfway between 3 pi over 2 and 3 pi would be 9 pi over 4. You can calculate that if you need to. All right, so then what we want to do is we want to calculate those values. Speaking of calculators, somebody sent me an email, and I will try to remember to also respond to you via email, because I read it and I didn't respond. You are not allowed to use the graphing calculators in here. You are, at the very beginning of the year, like the first day when we went over the syllabus, I think I had said we were able to use them, and then when I reread it, we are not. We are only allowed to use scientific calculators. So remember one of my last days here, we had all that, you know, trouble with the scientific calculators. That's why, okay? You need to be using just scientific calculators, no graphing. Otherwise, we just, instead of hand graphing these, we just stick them in the graphing calculator and be done with it. Okay, but not the case. All right, so anyway, I am using my graphing calculator on screen here just because that's the nice one that I have to pull up. But I'm not using graphing functions. Okay, so I am calculating 2 times the cotangent of 3 pi over 4 divided by 3. And make sure you're taking the cotangent of all of that. So you don't want to like end your parentheses and then divide by 3, or else you would be dividing the whole 2 times cotangent. We want to take cotangent of this divided by 3. So you need to make sure that your divided by 3 is part of what you're taking cotangent of. And hit enter, and we get 2. Now, we know there's symmetry, so what does that tell you about this value? It has to be negative 2. Calculate that if you want to double check it, but the symmetry tells you that that's the way it'll be. Okay? All right. Then you're just going to plot your points. So 0, we have an asymptote. At 3 pi, we have an asymptote. I totally missed that. So here's pi, here's 2 pi. At 3 pi over 2, okay, so that would be here, I have an x-intercept. I gotta move this line over, that looks terrible. Oh, I can't, it's connected. That's all right. I just want that to all be one thing here. Okay, and then at 3 pi over 4, I'm at 2. And 9 pi over 4, I'm at negative 2. Okay, now I want to connect these, and I want to make them have extend forever vertically. I really struggle with making those not look like a straight line when I'm drawing them. Hopefully you guys are doing better with that. And then you could just repeat this. If they ask you for 2 periods, do another period this way or another one this way. If they ask you for 3, do one each way. Okay, this is what it should look like. Okay. All right, let's try one more. y equals cotangent of x over 4. Okay, so why don't you guys pause the video and give it a try. Find your vertical asymptotes, your x-intercept, and then 2 more points and sketch it out. Okay, there's my kind of terrible sketch, but there it is. Here's also a little t-chart so you can check your values. Very short homework assignment tonight. So I hope that you guys make really perfect graphs here. Take your time. I don't know if I can pick up my baby crying there. I don't know if you can hear that or not. But make very neat graphs on this since you're only making 3. Make them real nice and neat. Get them looking good. All right, guys, have fun.